Alright, here's a Chemist Try video for advanced level or college level stoichiometry. Now, while stoichiometry is difficult, it's really not that bad, and once you get it, it's going to seem fairly straightforward and easy. We're going to go through two problems, and the two problems I'm going to go through, one of them is going to be fairly simple, just basic stoichiometry. The other is going to be determining a limiting reactant and the amount of excess left over. Number one, think of a stoichiometry, is kind of like it means measuring the elements. But think of this as, our balanced chemical equation and how much can I make of my unknowns and stuff. And my balanced chemical equation is nothing more than a recipe. That's exactly what it is. Here's a 2 dozen cookie recipe. And if I was to take a look and say, here's all my reactants, and if I add all of these together, I will create or produce 2 dozen cookies. Now, this is the coefficients just like in front of a balanced chemical equation. And if any one of these is short, like all of a sudden instead of 1 cup, I had a half a cup of chocolate chips, then that's going to limit how many cookies I can make. The rest of this there will be extra of, but I will use up all of those chocolate chips, and we call that the limiting reactant. Now, whenever doing any type of stoichiometry problem, we need to make sure we follow the steps correctly. Number one, create a balanced chemical equation. Number two, take the mass or the volume that we've been given and we turn it into moles. We have to relate moles of one to moles of another. I can go either side, product to reactant or reactant to product, but I have to be in moles, okay? And then once I get it to the moles of the unknown, the one they're asking me for, I can turn it back into mass or volume, but I have to follow those steps. So here's our first problem. How many moles of hydrogen gas would be required to completely react with 70 grams of nitrogen gas to create ammonia? So then, step one, create a balanced chemical equation. Make sure you remember Brinkelhoff, and if you have to do any review on balancing, see the video C3 Mr. Brinkelhoff or D4 balancing chemical equations found on the website. Alright, so it says we've got hydrogen gas, and we've got nitrogen gas, and we're going to create ammonia. Okay? And it said I've got 70 grams of nitrogen gas, and they want me to know how much am I going to have over here, but I only have to put it in moles. So then, step one is to balance my chemical equation. Remember, in balancing, the rules are balance all metals first, then nonmetals, then hydrogens, then oxygens last. I have no metals in this problem, but I do have a nonmetal of nitrogen. So I've got 2 nitrogen on this side, I've only got 1 on this side, I have to put a 2, so I put a large coefficient over there. Now my nitrogens are balanced. Now I'm going to work on my hydrogens. Over here now I have 2 times 3, so I have 6 hydrogens over here, I need 6 over here. Now I have everything balanced, and I have my balanced chemical equation. Step 2, take my grams and turn it into moles. So when I take a look at this and I get my conversion factor here of moles of nitrogen gas, 1 mole of nitrogen gas is 28 grams. Okay, I can cross cancel these. 70 divided by 28 is going to give me 2.5 moles of my nitrogen gas. Now, we're supposed to figure out how much of my hydrogen gas am I going to need. So we're going to go to the next page here, but we do have to remember what our chemical equation looks like, and this is 3 hydrogens to every 1 nitrogen that I go through. So let's go to a new page here. So we had 2.5 moles of nitrogen gas, and I need to figure out how much hydrogen. I always put where I want to go or what I'm looking for on top. So it was 3 hydrogen for every 1 mole of nitrogen gas. That's my conversion factor. So 2.5 times 3 is going to give me 7.5 moles of hydrogen gas is needed circle my answer, because that's all they asked me. If they told me to turn it, how much mass is this, then I would take my 7.5 moles and multiply it by 2 grams, because there's 2 grams per mole in hydrogen, cross cancel this, and that would give me roughly 15 grams, if that's what they asked me for. But they didn't ask me to go there, they just said how many moles. So I'm done with that. I have gone through all the steps, and I have come up with the answer. Let's look at another one. What if I did not have enough of one of my reactants? How could I actually, figure out how much product I could make or go through something like that? So here's a little more difficult problem. I got 316 grams of aluminum sulfide, and I gave you the formula for aluminum sulfide here, and these numbers here are supposed to be subscripts, but I couldn't get it down on this iPad. So I've got 316 grams of aluminum sulfide, and I'm going to add it to 180 grams of water. I'm going to create aluminum hydroxide and hydrogen sulfide gas. So hydrogen sulfide gas has a formula that's going to look like, because sulfur has a oxidation number of 2, so that's going to be H2S. I know that water is H2O. My aluminum sulfide is going to look like this. And that's going to mean that I'm going to have to then create whatever's left, which is going to be aluminum hydroxide. And due to the oxidation numbers, this would be what we look like here. So let's go to the next page and see if we can start doing some calculations. So, our formula, we had aluminum, Al2S3 sulfide plus water is going to create aluminum hydroxide, 3 of those, plus hydrogen sulfide, and it's actually hydrogen sulfide gas. Okay, so balancing this once again, now I have metals. Metals first. I got an aluminum here. There's 2 here, there's only 1 here, so I got to put a big 2 in front of that. Now I go to my non-metals. Sulfur is a non-metal. I got 3 here, but I only have 1 over here, so I need to get 3 sulfurs. Now my aluminums are balanced, my sulfurs are balanced. Next I move to my hydrogens. Okay, now if it's easier for you guys, you can think of water as looking like this to help you balance it. Okay, we don't break apart the hydroxides unless we have to. So since I have 2 times 3, there's 6 hydroxides, and there's 2 times 3, there's 6 waters, and that would be 6 of those and 6 of those, so all I got to do is put a 6 in front of this, and my chemical equation is balanced. Now, next step, we had 316 grams here, and we had 180 grams of water. So now we need to determine which one of these is going to run out first. We're trying to determine what's known as the limiting reactant, okay? So then, we need to turn grams into moles. And I gave you the, molar mass back on the other page. So 316 grams, and there's 150 grams per mole. And we know that water has 18 grams per mole. So that's going to give me 10 moles of water. And that's going to give me 2.11 moles of my aluminum sulfide. So now, many people would look and say, well, I got 10 moles of water and only 2.11 moles of this, my aluminum sulfide, so this is going to run out first. Well, that may not be the case, because I have to refer to my balanced chemical equation up here. And I have to look at what my coefficients are for each one of those reactants to determine this. So I always like to take the first one in line, not because it's important. You could have picked the water or the aluminum sulfide. I just usually start with the first one, which is the aluminum sulfide here, to determine if I have enough of it. I know I have 2.11 moles. Now, if I use all 2.11 moles of that aluminum sulfide, how much water am I going to need? Okay? So if that's the case, I would take my 2.11 moles of aluminum sulfide, and I'm going to say, okay, my conversion factor here is it's going to take 6 moles of water for every 1 mole of aluminum sulfide equals, okay, do the math, 2.11 times 6 divided by 1 means I'm going to need 12.64 moles of water. That's what I'm going to need. I'm going to need this much to use all of this 2.11. Okay, I'm going to need this much. However, I only have this much. That means I don't have enough. That means my limiting reactant is my water. Okay? My limiting reactant is my water. So when I do any type of product development, how much of my aluminum hydroxide I could make, or how much hydrogen sulfide gas I could make, or like we're going to do on the next page, how much excess am I going to have left, I can only use this 10 moles of water because that's the one that's running out first. So we'll go to the next page, and we're going to say, okay, we got 10 moles of water. Now, if that's the case, 10 moles of water, when it runs out, how much of this is going to be left, which is the excess reactant? So, my limiting reactant is my water. Okay, I got 10 moles of my water. We already figured out that's the one that's going to run out first. Okay, so now let's figure out our excess. So if we have 10 moles of water, and we remember our balanced chemical equation, which was where I want to go, I put on top 1 mole of Al2S3 aluminum sulfide over 6 moles of water, because this comes straight from my balanced chemical equation. That's where I get my conversion factors from. Then this tells me that I'm going to need, okay, 1.67 moles. 1.67 moles of my Al, because we can wipe those out. The only thing that's left is moles of Al2S3. Okay? This is what we're going to use. Okay? When I use this much of my aluminum sulfide, I will then have used all of my 10 moles of water. So, I started with 2.11 moles, but yet I'm only going to use 1.67 moles. So that gives me 0.44 moles of my aluminum sulfide left over. And if I had to turn that into grams again, we could just then take those moles, multiply it by 150 grams per mole, which is the molar mass which we had on the first page. Moles would cancel, that would leave it, and we would end up with 66 grams of Al2S3 in excess. Now, while there's a lot of math going on, it's very simple math. It's not all that difficult, and if you follow these steps, you know, it should be fairly straightforward. The best thing to do for here is practice. That's all I can tell you. Practice, 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 okay? So, this technique is used in every concept we're going to do in chemistry. This is the one thing you've got to get done right at the start, especially basic stoichiometry, okay? Use this video and review it as often as you need to, and anytime you have questions, bring them into class so I can, answer them. The biggest mistake AP chemistry kids or general chemistry kids do when they are working on this stuff is they say, this is tough, and they give up. And that is the biggest mistake. You never, never, never give up. Always stay gritty out there. Thank you.